Welcome back student to the series of the nanochemistry. So let's get start our interaction. Synthesis of nanomaterials. There are two approaches to the synthesis of nanomaterial, bottom up and top down. In the bottom approach, molecular components arrange themselves into more complex assemblies, atom by atom, molecule by molecule and cluster by cluster from the bottom. For example, synthesis of nanoparticles by dispersion. In the top-down approach, nanomaterial are synthesized from bulk material by breaking the material. The bulk solids are assembled into fine art pieces until they are constituted of only few atoms. Next process, wet chemical synthesis of nanomaterial. In that sol gel process we see sol are dispersions of collider particles in liquid, solid particles with diameter of 1 to 100 nanometer. A gel is interconnected rigid network with pores of sub-micrometer dimensions and polymetric chain whose average length is greater than a micrometer. A sol gel process is based on inorganic polymerization reaction. It is generally carried out at room temperature and includes 4 steps: hydrolysis, polycondensation, drying and thermal decomposition. This method is widely employed to prepare oxide materials. Reactions involved in the sol gel process can be described as follows. Metal alkoxide on hydrolysis gives the alcohol, and metal hydroxide also, and then metal hydroxide react with ROM gives ether. This process is the condensation. So the formation of different stable solutions of the alkoxide or solvated metal precursor. Second, gelation resulting from the formation of an oxide or alcohol bridge network by polycondensation reaction. Third one, aging of the gel means during that period gel transfer into a solid mass. Fourth one is drying of the gel. In this test, water and other volatile liquids are removed from the gel network. And last one is the dehydration. The material is heated at temperature up to 800 degrees centigrade. Here spelling mistake is there, not JAIL, here GEL is there. Please correct one. Next we see about the analysis for characterization of nanomaterials. In that, the synthesized material is analyzed by various analytical tools or techniques. Now we see about the history of nanotechnology. Nanomaterials have been produced and used by humans for hundreds of years. However, understanding of certain material as nanostructure material is relatively recent. Due to the development of advanced tools, that is sophisticated instruments, it has been possible to rebuild the information at nanoscale. Beautiful ruby red color of the ancient glass painting is due to gold and silver nanoparticle trapped in the glass matrix. Second example, the decorative glaze or metallic field known as the structure found on some medieval pottery is due to certain spherical metallic nanoparticles. Third example, carbon black is nanostructure material that is used in tires of car to increase the life of the tire. Carbon nanotubes are made up of graphite sheets with nano-sized diameter. They have highest strength. And last example is fumed silica, a component of silicon rubber coating sealants and adhesives, is also a nanostructure materials. Now we see about the applications of nanomaterials. First application is that nanoparticles can contribute to stronger, lighter, cleaner and smarter surfaces and systems. They are used in the manufacturing of scratch-proof eyeglasses, transport sunscreen, crack-resistant paint and so on. Second application is it is used in electronic devices, for example, magnetoresistive random access memory. Third one, nanotechnology plays an important role in water purification techniques. Fourth one is the self-cleaning material. Lotus is an example of self-cleaning. The lotus plant grows in muddy water. Its leaves always appear clean. The plant's leaves are a super hydrophobic nanostructure on lotus leaves, which repel water and carries dirt as it roots. Roots of lotus effect is the basis of self-cleaning windows. Now we see the nanoparticles and nanotechnology. Advantages of that. First is the revolution in electronics and computing. Second advantage in energy sector. Nanotechnology in energy sector will make solar power more economical. Energy storage device will become more efficient. In medical field, manufacturing of smart drug help cure faster and without side effect, curing of life-threatening diseases like cancer and diabetes. Now we see about the disadvantages of nanotechnology. As the nanotechnology has raised the standard of living, but at the same time it has increased the pollution, which includes air pollution. The pollution which caused by the nanotechnology is known as nanopollution. This kind of pollution is very dangerous for living organisms. Nanoparticles can cause lung damage. Inhaled particulate matter can be deposited throughout the human respiratory tract and then deposited in lungs. And last disadvantages is the characteristics of nanoparticles that are relevant for health effects are size, chemical composition and shape. Thank you.